Record. All right, this is being recorded. I'll post it today after class. So we've got the ray that has an endpoint, shoots off in a certain direction based on where the other point is lying. Vertex is when two rays come together. That point right there is called the vertex. This line that I created here is actually the angle that is created from those two rays. All right, an angle is just the union of the two rays with the same common endpoint. So we typically use Greek letters to describe an angle. So I want to give you a few of those to help you out here. Let's see, theta is my big one. I use theta. I use, sometimes you might see phi or phi or pho or phum. No, I'm just I'm horrible at drawing this one. There is phi or phi. I'm not Greek, so I'm probably saying it wrong. And then there's alpha. Beta, and then gamma. Those are the typical letters, Greek letters you're going to see to represent an angle in this section. Okay. All right. Let's talk about another piece of these angles, the initial side and the terminal side. So the initial side is where you typically start the first ray. And that's usually on the x-axis on the positive side. So given a faux Cartesian coordinate plane, this initial direction is towards the positive x's. And this is called the initial side. Okay. So we're going to have two rays, the first one being the initial, the second one is going to be our terminal side. And let's just create another ray. Terminal. That's the one that decides what degrees or how far from the initial side we're going. So we've got initial side, terminal side, we've got the vertex right here. And inside here is our angle. We'll just name it theta. Okay. Hi. How's it going? I'm recording this, so you will have a copy of it posted today. If you want to stay after class, I'll discuss with you anything you missed. All right. What questions do y'all have? This is just a bunch of vocabulary at this point. Prosper. Yes. These, no. These are just to let you know what representation of angles you may see. Not just in this class, I'm also trying to help prepare you for your next class going forward. So knowing that you may see a beta or a gamma, note that it's representing or in biopen math. I don't know what they're going to do to you. They could be representing something other than theta. Typically, my goal is theta. I stick with theta throughout my entire lecture. Okay. Greek alphabet questions, but I'll look into those on my own time. Yeah, it's fun. Okay. Any questions on initial, terminal, vertex, yada, yada, yada? I will share these with you afterwards. Great. Positive versus negative angles. All right. So if an angle is measured in a counterclockwise position, so let's start with our initial side. Here's our vertex. And if we are going in this direction, which is counterclockwise, our other terminal side will give us a positive. If it's going in this direction, it's going to give us a positive angle. Okay. Always starting from the initial side. Okay. Same thing, initial side. If the angle for our terminal side, you can go clockwise to get to it. That is going to be a negative angle. Okay, so if we're measuring it counterclockwise from the initial side, we're going to get a positive answer for our angle. If we're going the other direction and we're starting with the initial side, as we always have to do, and we're going clockwise, it will be a negative angle that we will represent. Okay. All right, I'm shifting up to standard position. Standard position is just drawing your angle that always starts at the initial side, which is, again, I'm going to give you a Cartesian coordinate system. There's our XY coordinate. Oh, let me move this up. Our initial side starts along the positive X axis. Okay, so this is where we start our initial side. To place the terminal side, we must calculate the fractions of the rotation. So you need to understand, first of all, that if I start at my initial side and I create an angle all the way around and back to my initial side, that gives me 360 degrees. Okay. And we'll get you there to the next step. The next thing is going to be talking about 1 degree. Well, hold on. Keep or find the coterminal angle within the positive or negative 360. Not yet. We're not there yet. Calm down. We're not talking about coterminals yet. Okay. I know where you're heading. Okay. We're going slow. Okay. Because we have people who've never heard of what a coterminal angle is. And so I want to get you there slowly. So we've got an initial side. In order to find out, what each of these, let's just say this one here is, let's just say this terminal side, then to find out whatever your terminal side, what the angle is created from this, so theta is going to be positive. Okay. And it's going to be one of the degrees between 0 and 90. Because this is 0 degrees, all the way back around again to 0 is 360 degrees. And if it's straight up and down, this is where we get that 90-degree angle. So this has to be somewhere around, I don't know, probably more like a 60-degree angle, but it would be positive. Let's talk about degrees now. Let's go to 1 degree. You have a question? Let's go to 1 degree. How the heck are we going to figure out what that looks like? Okay. All right. Well, we know that all the way around, back to the initial side is 360 degrees. So for 1 degree, that's equivalent to 1/360th of the circle. So 1 over 360 is equal to 1 degree. Okay, and that's the representation we're going to use for degree. I'm going to give you some degree, seconds, minutes, some different, not just the terminology, but what it looks like as well. I'll think of the word in a minute. Symbol, there we go. So let's talk right angle. To draw a 90-degree angle, you have to have your initial side first. You always start with your initial side, which is representation of the positive X axis. Okay. And to draw that 90-degree angle, what we can do to figure out where it fits on this circle, you take that 90 and divide it by 360. When you do that, you have to reduce. And this is something y'all are going to have to get comfortable with at this point. This section is going to require you to learn how to reduce numbers. You got a haircut. You would have to see this. All right. So because I know to reduce this, 90 goes into 360 4 times. So this is just 1/4. So if I'm thinking of this entire thing as a circle, here's my vertex. 1/4 of that circle is going to be, I am horrible at drawing straight lines, straight up and down to where this angle to my terminal side is going to be 90 degrees, also represented by a cute little square. Okay. So the terminal side is 1/4 of the way around the circle. Okay. And it has to be positive because we're moving in a counterclockwise position. All right. Let's talk straight angle. Kind of already looked at the straight angle a little bit. Anytime we're talking about angles, again, I'm going to draw my initial side. At some point, I'll stop writing initial side. And then a straight angle is literally all the way around and back to 360. That's 360 degrees. It is both the initial side as well as the terminal. Okay. There's some pieces I'm about to cover that is not listed in your guided notes. So I'm going to add a couple of things because I want to make sure that you're comfortable with knowing your quadrants in case you're asked those. All right, I'm going to shift this up a smidge. So I'm just going to draw 4. I don't know why 4, but we'll do 4. To represent each of the quadrants. So quadrant 1 is always positive, positive. All right, it's always going to be a positive quadrant. All right. Representation, if you have a line, your initial side is here, and there's no movement, you've got a secondary ray on top of it. So this is an imaginary thing because I can't create this. I guess I could. So say we have an initial side of green, and then it creates there's a second ray that's directly on top of it. And I'll make that one in red. That's a 0 degree angle. That is a 0 degree angle. This is quadrant 1, quadrant 2, quadrant 3, and this last cute one over here is quadrant 4. Okay, they go counterclockwise. I also want to talk about, we just did the 90 degree one. So if my initial side is here and my terminal side is here, then that creates my 90 degrees. So this is a 90 degree angle. Okay. 180 degrees is where you've got your initial side here, and you've got your terminal side over here, which creates 180 degrees or a straight line. Last one I want to talk about, 270, because we already talked about 360. 270, initial side here, terminal side here. Remember, I'm going counterclockwise, so all the way around this bad boy is 270 degrees. The quadrants will come into play when we get to the next, probably the right triangle trigonometry on Thursday. Today's Tuesday. Okay, so these are called quadrantal angles. The last one, I just want to make sure you have it here because it too is a quadrantal angle, is the same as the 0 degrees. And it is where you've got your initial side. You go all the way around with this angle and back to here, and you get 360 degrees. And these are all representation of quadrantal angles. That's when the terminal side is hitting an axis. It's either going to hit the x-axis or be on the y-axis if you're thinking of the Cartesian coordinate system. Okay, it's just a terminology. I'm not going to question you about define quadrantal angles, but you're going to need this terminology moving forward. Okay, because you're all moving forward. All right. Next victim. Draw the following angles. Well, I don't have a protractor and I'm not really good at these, but I'll do my darndest. Okay, so 60 degrees. Cartesian coordinate system, I tend to always draw that. I need to know where my initial side is. And then the way I look at this is I break down, because I know if it was straight up and down, it would be 90. If it was directly halfway in between, it would be 45, because half of 90 is 45. So it needs to be just a little bit past halfway. And that's going to be my terminal side. This is just sketching. It's not going to be actual. So from initial to terminal is 60 degrees. Okay. Negative 120 is a different beast because we are no longer going counterclockwise. In order to have a negative, which I talked about earlier, in order to have a negative angle, we have to start at that initial side. This doesn't change. You always start at your initial side. But instead of going counterclockwise, we're going to go clockwise. So we're going to move like a clock. All right. I know that from here to here is 90 degrees. From here around to this line is 180 degrees. Okay. So this one's 90. This one would give us 180. I have to think through what's happening here. 9, 10, 11, 12. So it's 30 degrees difference between here and here. So probably more like right here. Should I use my red? And understand that your angle is not like this one. It is going this way. So it is negative 120 degrees. It is going clockwise. The next one's not as hard either because it is just negative 240. So draw my Cartesian coordinate system, initial side. Okay. And we're going clockwise. So I'm going in this direction. That's 90. This would give us negative 90 degrees. This would give us negative 180 degrees. This would give us negative 270 degrees. So we want to be in quadrant 2 somewhere. So how much is that? 18 to 27, 20, 1, 2, 3, 4, 24. So that'd be 6. Yep. So it's literally halfway in between. No, it's not 45. So right about here, 60 degrees. And that's going to give us, going this direction, always have your line start on your initial side and point towards your angle. If I'm asking you to do this on an exam and I'm wanting you to draw this, I'm not expecting you to go to Desmos or anything to draw it. I literally want you to take your line, start on your initial side, and show me where your angle is ending up. Okay. All right. So that's negative 270. The last one is 405. Well, hold on a minute. If this is 0, 90, 180, 270. This is also 360. How am I going to get to 405? I'm going to subtract 360 from 405. 405 minus 360 tells me that I have a 45 degree angle. In fact, they're equal. 405 is equal to 45 degrees. So initial side, 45 is directly in between the 90 and 0. But when you draw it, you're going to start on your initial side, go all the way around through your initial side and back to your terminal side at 45 degrees. Okay. Questions? Yes, yeah, to find out what the, because it could be 720, it could be 840, it could be crazy. But you would start subtracting the 360s until you get something that's less than 360 so that you can know where it's hitting. Okay. That help?
So if there's more than 720.
You just keep going minus 360 until you get to a point where it's between 0 and 360. And then it's actually equivalent to that. It's the same exact angle. You just have to show your wrapping. And I don't mean wiki, I mean draw. Yeah. Okay. All right. Any other questions about this? All right. Define the following terms. All right, this is where I'm going to give you not just the terminology, but also the symbols that represent them. So degrees, each of the degrees of your circle have 60 minutes of them. Think of it as a clock. And in this case, the degrees are going to be representative of the hours, quote unquote. So the symbol for it is the cute little circle up here. All right, but you would say something like 60 degrees. The cute little circle is your degrees. And degrees are divided into 60 minutes. Okay. So the next one is minutes. So you've got 360 degrees around your circle. So each of those degrees has 60 minutes in it. All right. But each of those minutes are going to have 60 seconds in it. So minutes are divided into 60 seconds. The symbol for them is, so let's just say it's 60 degrees. I'm going to keep the one we have up here. 35 minutes. So this is the symbol for degree. This is the symbol for minutes. Just a little, what is it for, like can't, C-A-N apostrophe. It's just an apostrophe. Apostrophe is the symbol. Okay. And the last one is just seconds. That's the smallest terminology we're going to use in this class to represent. So we've got degrees. The degrees are broken down into 60 minutes. Each of those minutes is broken down into seconds. Seconds are represented by quotation mark. So if we've got 60 degrees, 35 minutes, and we'll say 5 seconds. Quotation mark represents seconds. Okay. We're going to learn how to convert both directions, converting from degrees, minutes, seconds to the actual degrees and vice versa. Okay. What questions do you have so far before we get into this? This is where it's going to get a little tricky for folks. But if you keep the method I'm about to show you, you should be fine. Okay. Question.
Seconds are kind of like 8 inches.
I know. It's actually more like time. There's 60 seconds in a minute. There's 60 minutes in an hour. I always think of it as time more so than anything. Talk to me. What's the look, Emily?
At the I think just different things.
Is it really?
It's not that much different. But it's not a- Just like.
What, is it what I showed you? Is it what I posted?
Yeah.
Really?
Well, it has number 12 as those definitions, and then it goes to 11. My other numbers were off.
I'm sorry.
No,
Don't know why. That's, well, I did some changes, but not after I shared it with y'all. Okay, I'm sorry. That's crazy. I shouldn't even number the darn stuff. Okay, so I'm just going to represent 40 degrees, 15 minutes and 38 seconds and to a decimal in degrees. Okay. And I'm going to give you how to do that. If you just follow the same method throughout, you will be fine. All we have to do is, well, 40 is already in degrees, which is what we're heading towards. So I'm not changing this sucker at all. So 40 plus 15 minutes, I'm going to just take that 15 minutes and multiply by 1/60 because it represents the minutes in a degree. Okay, so that represented the minute. And then last, I'm going to add my seconds. But I have to, this is a unit conversion that we're doing here. So we're going from seconds to degrees. So we're going to have to multiply by 1/60 to get it to minutes times 1/60 again to get it to seconds. Okay. If you do this, you're going to get an answer. Let's see what we get here. 38, I'm just going to divide that by 3,600. So that's 3,600 on the bottom. 600. Or you could do 38 times 1/60 times 1/60, totally your call. I do not clear my calculator as I'm doing this. Plus 15 times 1/60, we'll just do it this way. And then plus 40. And I get 40.260555556. All right, so my answer is 40.2, we'll just go 26056 degrees.
At least you don't want us to round up.
I'll tell you at the time.
Okay.
Yeah, I'll definitely tell you what to round to. Yeah, talk to me.
I was writing something.
No, please.
Why is it so?
Because this is representing minutes. This one will take us to the seconds.
Okay.
Because right now it's just in seconds, but we need to knock it out from seconds, minutes, is degrees. Okay. Any other questions on this?
Yeah, why don't we just write 1/60?
You can. You can. I'm just trying to show you that it's going from seconds to, yeah. Just do that. You know you can do that. So he was just asking, why don't we just write 1/3600? You can do that. I'm just trying to show you how it gets us there. Because this one gets us from minutes to degrees. This one gets us from minutes to degrees, but it's in seconds. So we need a second one to represent to get us to seconds to degrees. But yeah, just multiply times 1/3600. It will be all Gucci. Any other questions? Okay. And number 52 is convert 32.584 degrees. And we're going to take it to degrees, minutes, and seconds. Okay. So I don't have to do a stinking thing with the 32 because it's already in degrees. So I've already got 32 there. I can put a cute little degree symbol on it and I'm done with that one. Now I need to move the minutes. Oh, I need to get to minutes. How do I get to minutes? Well, I take that 0.584, 0.584, and multiply it by 60. Let's see if I can do a light on this one. I just want to show y'all what oh, Lord have mercy. Nope, that didn't help. So I get 35.04. I'm trying to show y'all. There we go. I got 35.04 here. That 35 is going to be my minutes. So I've now got 32 degrees, 35 minutes. And I'm left with 0.04. Okay. You take the whole numbers. So we've got the 32, we've got the 35. Now we're going to take the 0.04, multiply it by 60. And I got 2.4. You do round at this point. So because it's not 0.5, I'm just going to take the 2 seconds. Okay. There's
How come we don't multiply that by another 60?
because it's already been multiplied by 60 here, and it got us 35.04, and that took us to minutes. Multiplying by our second 60 is going to take us to seconds. So we did the 2 60s. Does that make sense?
Okay,
Okay. Yeah, just make sure when you do your first 60, you take that whole number out of there. The decimal that's left is what you're going to use to multiply by 60 again to take it to seconds. You release the decimal that's to the right. Do not give me a decimal for your seconds. You will either round up or leave it as the 2. Okay. So there's our answer for that. Any other questions? Okay. So says you have a function on your calculator that will do this for you. You also have 2 modes in your calculator, and this is the thing that screws the pooch for everyone on their exam. If you're going to mess up on your exam, inevitably, it's having it in the wrong mode, whether it be degrees or radians. Make sure you're in the correct mode when working on problems in this section. So currently we are in degrees, so your calculator should be in degrees. Once you start seeing a cute little pi symbol pop up, however, you have just moved to radians. All right, and we'll talk about that here in a second. All right, define the following. Central angle. Central angle is just one that's formed at the center of the circle using, okay, let's do a circle. I want to show you. So here's a circle, don't judge, I'm not an art person. Here's my center. I've got a radius here. Radii. There's another one right here. Okay. The angle that is formed using those 2 is considered the central angle. Goodness. All right, y'all are gonna have to excuse me for a second, talk smack, whatever you gotta do. I'm gonna pause the video so y'all don't have all this recorded because I don't want to know what you're saying. Pause. Ooh. All right, let's Zoom recording again. All right. Whew. Let's see here. What are we doing next? 1 radian. All right. Well, 1 radian, we're now hitting a different level. Radian is just a measurement of the central angle. It talks about the arc length. I'm going to give you some information. Let me draw another quote unquote circle. Let me move this up. All right. So we've got, let's do our radius. There's a radius, a radii. Let's draw another angle. It's also going to be a radius, but we've got our central angle here. This one is representative of 1 radian. the arc length is equal to the radius. I'm going to explain to you that here in a second, is equal to radius. The arc, not of the covenant, but the arc that is created from these two radius is this bad boy right here. It is the same length as the radius. Okay. That's 1 radian. All right. So I'm going to show you a value of, let's just say 1.2 radius. I want to show you how I would represent that because I want to make sure you have the terminology as well. I'm going to use rad. So if we say there's a radius of 1.2 radians, or just say this one, we can say rad. I do want to show you some things you might see in other classes as well. If it's not just 1 rad, they might just use a capital R. I'm going to be consistent and use rad, but these are some other things you might see. 1 R, 1 rad, 1 little r. You might see even 1 C, central angle. Okay, those are some things you might see. I'm going to use RAD because it's rad. Yes, I'm being a nerd. All right, let's go on. Definition of arc length. Well, I just drew you a picture of it. For a circle of radius r, the central angle of theta radians, which is just the angle size, creates an arc. So let me draw it again. Here's my circle. Let's see what else I want to say on here. Is there anything else I had in my notes? Oh, I'm going to give you the formula. So theta radians subtends an arc whose length S is the curve along the arc. The curve along the arc. And in this case, let's just create, we can just use these two. Okay, there's the arc length. So we can find an arc length using a formula. The arc length is produced by any given angle. So it doesn't matter which angle it is, it has a constant relation to the radius. Doesn't matter what the length of the radius is. Okay, and that formula is S equals, and S is the arc length, S equals R times theta. Okay, S is the arc length. I'm going to write that over here for you. S is arc length. R is your radius. And theta is your angle, central angle. Angle, here's the big part, in radians. The angle has to be in radians. Okay. And there's your formula for that. You can find, with this formula, you can solve for theta. So you can find your angle, you can find the radius length, and you can find the arc length, all by solving for each of these. Just a little bit of algebra to make it pretty. And in fact, I'll do it for you. If I were to divide both sides by r, I would get that theta is equal to the arc length divided by the radius. And then the other one, if I divide both sides by theta, I would find that the radius is equal to the arc length divided by the angle. So there's your 3 formulas that you can use for those, just by manipulation. Little algebra. Okay. So this next one, we're going to use that formula. We're going to find the length of the arc of the circle. So we're going to find S that has a radius of 2 meters, subtended by a central angle of 0.25 radians. So notice we're talking about meters and radians here, two different units that we're talking about, but our answer is going to be arc length, and that's going to have to be represented by meters because that's the only one that's measuring length in this case. So with S equals R theta, S will equal R is 0.25. I'm so sorry, the radius is 2 meters. I am losing my mind. S equals 2 meters times theta, which is 0.25 radians. Two times 0.25 should be 0.5. So the arc length is 0.5 meters. Radians is the equivalent of saying degrees. So it just has to do with how far around the circle it is. But the measurement portion of it is meters. So that's what you're going to have to use to represent. Okay.
So that's also the radius.
The radius is 2 meters.
Correct.
Based on the central angle being 0.25 radians, we're getting a 0.5 meter for your arc length. No worries, don't apologize. Can you show me how to reduce a decimal into fraction in rad? Decimal into fraction, like take the 0.5? Is that what you're trying to ask me, Marshall?
No, on the homework, like one of the decimal answers was like, for example, it was like negative 8.0622. And
Okay.
they wanted it in fractions over, what was it? It was fraction pi over the radius.
I'm not there yet.
Oh, okay, I'm sorry.
No, you're fine. I'll get you there, all you overachievers. I will get you
Yep.
there. We're just not there yet.
Okay.
I'm not going to leave you hanging. We're getting there. All right. So moving on. Answer the following. Come on in. Have a seat. So one revolution is equal to how many radians? Well, one revolution, and we're going to start thinking a little differently here. We talked about a revolution earlier. We had the initial side on the positive x-axis. And then when we took the terminal side, went all the way around and back to it, that was 360 degrees. That we know one revolution is equal to 360 degrees, right? That we know. But the other thing, the new part of this, is that one revolution is equal to 2, legitimate, is equal to 2 pi. Okay. Anytime you see pi, we are now in radians. You will not see pi in degrees. Okay. So one revolution from the initial side all the way back around to that same side is going to be 2 pi radians. All right. So if that's the case, 180 degrees, which we talked earlier is from the initial side and it creates a straight line. It's half of 360 degrees. So it's half of 2 pi. So it's only pi radians. Okay. I want to give you this is the part where I'm going to give you a formula to utilize, but I'm also going to give you a little cheat to it as well. All right. So if you're converting from degrees to radians, let me see if I gave you that formula thing here. Hold on one second. Nope. So I'm going to give you a couple things. I'm going to start with this. You're converting between radians and degrees, no matter which one you're going from. I'm going to put my degrees on this side and my radians on the other. So you understand what I'm looking at here. So I've got theta, my angle, divided by 180, and these are degrees. Oh, can't see that. And then radians is the angle in radians, and that is going to be divided by pi. And I'll show you how I'm going to use this. And then I'm going to show you another trick. No, I'm not. I'm going to show you the other trick first. All right, so I'm going to leave that there and pull this up. So to convert from degrees to radians, all you're having to do is multiply it by pi divided by 180. That's all this is showing us. To convert from radians to degrees, all you're going to be multiplying by is 180 divided by pi. Okay, this is going to do the same thing. It's just a little bit easier for folks to see. They mean the same thing, so don't think you're writing two different things. All right, let's actually do one of these suckers. All right, so we're going to convert 90 degrees to radians. Okay, well, I just told you to convert from degrees to radians, we multiply by pi over 180. So taking 90 times pi divided by 180. To me, this is the easiest way to do it. You're going to reduce. You're not going to use fractions, and you're not going to use decimals anymore. You cannot use decimals on this. You have to use the reduced fraction. This is not an option. Okay, so you're going to take this and you've got 90 pi over 180. You're going to reduce them both by 90. 90 goes into 90 one time, so pi. 90 goes into 180 two times. So there is our radians for 90 degrees. It's pi over 2. Do not use decimals at all. It will be wrong. You have to learn to reduce. I'm sorry. If you need help, I am more than happy to help you. Okay, but you've got to reduce it. I will, how to reduce. Okay. Oof. I haven't explained this in a while. So let's just take 90 pi over 180. To reduce, you need to find out what numbers will go into both of them evenly. The first thing I'm going to do, if I'm going to make this easy on myself, is boom, the zeros are gone. Right? 10 divided by 10, it's 1. But now I've got 9 over 18. 9 will go into 18. Golden, right? 9 goes into 9 once, 9 goes into 18 twice. So that's 1 pi over 2, because 9 goes into 9 once and 18 two times. Representation, do not put a 1 in front of your pi, just make it pi over 2. As we go through the next ones and do more of them, I will reduce them. I'll break them down and show you what I'm thinking as I'm doing that, so that if you're struggling with the reduction, I'll be happy to show y'all how to do that. If you're still struggling at the end, please make sure and touch base with me so that I can help you. Okay. All right, let's look at negative 270 degrees. Okay, so again, I'm going from degrees to radians. So negative 270 times pi over 180. That's equal to negative 270 pi over 180. First thing I do is reduce by 10. Zeros are now gone. I don't like big numbers. What number will go into 27 and 18? That's what I have to ask myself. 9? 9, 8. Will 18 go into 27? Because 18 times 2 is 36. So I'm going to go to probably 9. I'm going to start breaking it down. 9 goes into 27 3 times, and 9 goes into 18 2 times. So that's equal to negative 3 pi over 2. Does the logic make sense to you? Are you comfortable with that? You will have plenty of practice at this on your homework. If you struggle with it, let's talk, because I want to get you there. You got to find what they have in common and start reducing it. That's it. If you have to take it by 2s, by 3s, whatever it takes until you're comfortable with it. If you don't know your multiplication skills, you're going to struggle. If you don't know them, please learn them before you move to pre-calc, because it's going to eat your lunch. That's the biggest issue I find with these students is you were not forced to learn your multiplication skills, and that's going to eat your lunch. Okay. All right. So let's move to convert the following radians to degrees. So we just moved from degrees to radians by multiplying by pi over 180. We're going to flip that sucker and take the reciprocal of 180 over pi, multiply the radian that we have here with it, and it's going to take us to degrees. So I'm going to take the negative 7 pi over 6 times 180 over pi. When I do this, I'm not going to multiply that 7 times 180. I'm just going to leave it like it is. I'm going to show you what I do whenever I see this. Okay. First of all, the pi's reduce. Okay, because you're not going to have a pi in your answer for degrees. That's the reason why we put it there. The next thing I look at, 7 and 6 do not reduce. If they did, they'd already be reduced. So I'm going to take that 180 and the 6. I'm going to look at these two numbers and I'm going to reduce them. I know 6 goes into 180 because 6 goes into 18 3 times, because 6 times 3 is 18. Just telling you how I'm thinking through this. So 6 goes into 6 once. 6 goes into 18 3 times, but there's an extra 0. That's my thought process through this. At that point, all I have to do is now multiply that negative 7 times 30. That's all I have left. There's my degrees. And I should have put rad on these. But if anytime you see a pi, you already know it's radians. Negative 210 should have a degree. Prosper. I don't, so that's what I was just saying. If you have a pi in your answer, it's radians. It's already radians. I know that. And it's going to be a point where you understand it as well. The 210, however, please put the degree for representation. That's the one I do want you to definitely have in there. Please make sure you have the cute little degree symbol for your degrees. Okay. Is this new for you, Jake? Is this new information? You've seen this stuff before.
I've never dealt with degree stuff, but can we find that?
Oh, you're good with that.
Yeah.
Okay. So let's keep going. The next one, we're going to multiply by the same thing because we're going from radians. I know it's radians because it's in pi. I'm going to multiply it by 180 over pi. Pi is gone. It reduced. All right, 2 and 3 do not reduce. However, the 180 and the 3 will reduce. I know 3 goes into 180. 3 goes into 180 60 times. 3 goes into 3 once. 2 times 60 is 120. Is that helping? Marshall, is that helping with your reduction? I will come back and do the other one you had, the 1.5708. He had that in the, I'm not crazy. It's actually on my chat over here to show you how to do that. Okay. Oh, last page. Okay, we're just drawing angles now in standard position. So this is where I'm going to show you the trick, not in this one, but in the next one. So the first one here, draw an angle in standard position. It just means you have the X, Y, X, Cartesian coordinate system. Your initial side is always your positive X's. So here's my initial side that I'm starting with. All right, 30 degrees. Well, if we're just sketching, because I don't have a protractor, I know that this is 90 degrees here, and we're not going to go that far. Half of that angle would give me 45, because 90 divided by 2 is 45 degrees. So it has to be a little bit slimmer than 45 degrees. Okay. So this angle starts at the initial side, goes to your terminal side, and your theta is equal to 30 degrees. You could just say 30 degrees too. Okay. The next three are in radians. Different beast completely. I want to show you my trick that I use for this, but I also want to show you what your support system is for this afterwards. So you've got access to almost all of the radians on the circle, and I'll show you that here in just a second. But my trick for this, anytime I think of a circle, I'm always in my mind thinking of it in degrees. That sucks. That's how I know of it. So if I'm doing that, please don't think of this as any other way than how to draw it. I always use pi as equaling 180. It equals 180 degrees. Okay. It's sleeting here. Don't know if it is at your place. It's not fun. So 2 times 180 divided by 3. And I'll even show you how to reduce this. 3 goes into 18, 6, so that's 60. So that's 120 degrees. That's how I think of it. It's a little bit easier for me to think about graphing it when I know the degrees, because then I can be like, oh, this is 0, this is 90, this is 180. So I know it's going to be in quadrant 2 somewhere, but where? I think it's 30 degrees off. Yeah. It's not directly centered. It's going to be up just a little bit closer to the 90 degrees. That is a straight line. So here's my initial side. Here's my terminal side. And here is my angle, starting at the initial, goes over to here. But you're not going to label it as 120 degrees. You're going to label it as 2 pi over 3. All right. Talk to me.
I just want to share my little.
I would love to hear it.
Whenever I see pi, I know that I want that pi to cancel out, so I can put pi on the bottom and then you know pi over the.
Yes. Yes. You can do that way just to change it to, yeah. Perfect. Talk to me.
For quizzes or exams.
Yes, you can use your notes. And that's what I was going to show next. On your notes, your very last page in this notes has your unit circle. So I provided you, now keep in mind, this is only the positive versions. You might want to stay out for just a second, but I'm sorry, Emily, so I can go over some things with you. No, you're fine. I want you to see my trick. You have this on your notes. It's the very last page. You are going to want, yes, exactly. Marshall, you're spot on. You're going to want to have access to this when you're doing your homework, when you're taking your quizzes, your exams. In your next class, you're going to memorize this. You're going to have this memorized in pre-calc. They will force it. Hello, a cheat sheet. Yeah, right. It's on the last page. You didn't look at what you printed. Okay. So I'm not going to use the cheat sheet. I'm going to go back and do it the hard way. And you're not going to miss anything. I'm going to show you what I did again. So again, here's my XY. You could just flip it over and say, okay, we're 7 pi over 6. It's going to be right there. But say you don't have your unit circle in front of you. And you're like, well, shucky darn. You can just use 180 for pi. And what I did was I just substituted pi for 180. So 7 times 180 over 6. See ya. All right, so that just reduces to 30. So that's 210 degrees. 90, 180, 210, because that's 270 right here. Okay, so initial side, terminal side, angle. And make sure and label it 7 pi over 6. Or use your unit circle. Because the unit circle that I provided does not give you the negative versions of this. This is when using the 180 for pi makes it look a little prettier. All right. So if I take and substitute 180 for pi, that's negative 180 over 4. I know 2 goes into that, but what is that? Is 4 going to 180? 180 divided by 4. Sure as heck does, 45 degrees, but it's a negative 45 degree angle. So looking at our, again, initial side is always our positive X versions. If we're going negative, that means we're going down. Say it again. No, the initial side is going to be going towards the positive. In this class. Okay, so moving this way, I know this one is negative 90. Halfway between that sucker is our negative 45. So this angle right here, because we're going clockwise, is negative pi over 4. All right, again, you've got all the positives represented for your unit circle on the back of your notes. But the negative, you just got to understand that you're going clockwise at that point as opposed to counterclockwise. Questions? Comments, quotations? I'm done. That's it for 7-1. You already know the answer. I'm going to stop the recording. I'm going to download it and I will share the recording